Hello, my students. Again, my name is Chintu Herbert. I would like to welcome you back again to this lesson of ours, still under solving simultaneous equations. I hope you're safe. You stayed home, just like you were instructed, because when you stay home, you stay safe. I thank you so very much. Now, previously, we were talking about solving simultaneous equations, and we said that we had four approaches to use. We had the graphical approach, we had the substitution approach, we had the elimination approach, and we have the matrix approach. Now, but so far we have looked at the two, that is the graphical and the substitution. That leaves us with the other two, which are the matrix approach and the elimination approach. Today we would like to center our attention on the elimination method. In some books, you're going to find this. They refer to it as the addition method because you're adding one equation to the other. Now, this method works because of two items. One, it works because adding one equation to the other does not alter the truth of the equation. And then, further still, multiplying or dividing the expression on either side of the equal sign by the same number yields a valid equation. So, for this method, we shall say, note here, that it works. Why? Because multiplying or dividing the expression on either side of the equal sign does not alter the validity of the equation. Further still, again, that adding one equation to the other yields another valid equation. So those two make this method work efficiently. Now, what is our procedure here? In our procedure, one, we identify the unknown variable to be eliminated, from both equations, and then what do we do with it? We manipulate the equation such that the coefficient of the variable to be eliminated is the same in both equations. Coefficient of the variable to be eliminated is the same in both equations. So, what do we do? After having ascertained that the coefficient of the variable is the same in both equations, this is what we do. Next, we add the two equations if the sign of the coefficient is different. Otherwise, we subtract. Now, with this background information, it's going to be easy for us to move ahead. For us to be able to move ahead, we're going to use two examples, which we are going to walk through using these procedures we have put down. So as an example, this is what we're going to have. Solve the simultaneous equations below using the addition method or the elimination method. And these are our equations, where we have x plus y is equal to 6, and then we have 2x less y is also equal to 6. So there we are. We have our equations. So the task at hand is to ask ourselves, how do we proceed from here? We could call this equation 1, call this equation 2. Please realize that the y term in both equations has coefficient 1. The coefficient 1. But the sign is different. So if the sign is different, what have we said? If the sign is different, we simply add the equations. If the sign is the same, then we subtract the equations. So please realize here that we have from equation 1, x plus y is equal to 6, and then 2x less y is equal to 6. So what we are going to do is add vertically. Please realize that the coefficient of y here is positive 1, whereas here it is negative 1. That being the case, realize that when we add a positive to a negative, the result is 0. Why? Because positive 1 is the additive inverse of negative 1. So here, when we add vertically, we are going to have 1x plus 2x gives us 3x. Realize here that positive 1 plus negative 1 gives us a 0. Whereas they said 6 plus 6 is equal to 12. Now this is what we say, that when we add one equation to the other, on the left, and we do the same to the variables or to the constants on the right, the resulting expression is true. It holds true. In which case we are having here, so what we do next here, we are going to drop the 0 term. Now when you do so, you're going to have 3x is equal to 12. Now after dropping the 0 term, realize that you are left with an equation which has only one variable, and that is x. This one can easily be obtained using the usual methods of dividing both sides by 3. So here, when we divide by 3, we are going to have that x is equal to 4. Now, when we get x as 4, we are halfway there. We are not yet there, but we are halfway there. So what do we do to get the value of y? So we are going to say that substitute the value x is equal to 4 into any of the original equations. Now this will help you to find the value of y. Very simple. It's not so hard. Because we know that x is equal to 4, but then we are given that when we use equation 1, realize that x plus y is equal to 6. However, because our x is already obtained as 4, we shall put 4 here plus y, and we shall put 6 there. So what we do next? Please realize that this is an equation in y, which we can solve to get the value of y as easily as you possibly can do that. Please realize that for us to be able to get the value of y, we are going to transpose 4 so that we may have 4 less 4 plus y is equal to 6 less 4, in which case we have y as being equal to 2. Then we come and say here that therefore the value of x is 4, whereas the value of y is 2. Now this is our solution. That is our solution. Very simple. As easily as that. Please take time to read through the instruction. Flow through like a river flows slowly but surely into the sea. You do the same. You eventually get there. Now, to help those of us who have some doubts still, I'm going to give us another example. Example 2. The simultaneous equations. Solve the simultaneous equations by elimination method. And these are 2x plus y is equal to 8, 2x plus y is equal to 8, and there we have, its sister equation is x plus 3y is equal to 9. So there we are. That is our presentation. That is our example, which we have to solve to get the value of y and the value of x. We are using the method of elimination. In other words, we have to get rid of one variable, and we have only one equation which has only one variable, which we can easily solve. Again, given, call that equation 1, call that equation 2. So in your mind, ask yourself, what do I want to get rid of? After answering that question, then you look at the coefficient of the variable that you want to get rid of. If it is the same in both cases, in both equations, then ask yourself, is the sign the same? If the sign is the same, simply subtract one equation from the other. If the sign is not the same, simply add one equation to the other. If the coefficient is not the same, then ask yourself, what is the LCM of the coefficient of that unknown in equation 1 and in equation 2? For example, let's eliminate x. Now, when we look at equation 1, the coefficient of x is 2. Whereas in equation 2, the coefficient of x is 1. How can we make this one 2? Now, we can make this one 2 by simply multiplying this equation by 2. By 2 here, by 2 there, by 2 there. Now, this is going to give us 2x plus y is equal to 8. And then we have here x plus 3y is equal to 9. But we are multiplying this one by negative 2. Now, if you multiply through by negative 2 here, here, and there, the resulting equation is still valid because what you have done here, you have done the other side. Now, this yields something of the kind. The equations you have are now, we have equation 1, which was 2x plus y is equal to 8. And then we have, when you multiply here by negative 2, this yields negative 2x. When we multiply this by negative 2, it yields negative 6y. Whereas when you multiply this by negative 2, it yields negative 18. And there you are. Please realize that the coefficient of x here is 2, it is 2 there. The sign here is plus, and here it is negative. So what you're going to do is add one equation to the other because the sign is different. Now, when we do that, the positive 2 and negative 2 cancel each other out. This will give us 0x. Whereas here, we're having a positive 1 added to a negative 6 to give us a negative 5y. On the other side of the equation, where we are adding vertically 8 to negative 18, this would give us a negative 10. So what we're going to do is drop the 0 term. In other words, this yields negative 5y is equal to negative 10. It's an equation which has only one unknown, and the unknown being y. That being the case, what do we do with this one? Because there is a multiplication here, we know that multiplication and division go hand in hand. So what you're going to do here is 1. The procedure you carry out here is division. So you're going to divide by negative 5 on both sides. This would give us y as being equal to 2. Now, after getting the value of y, we can smile because we know we are halfway there. At least we have done something, but we are not yet there. The solution that we are requiring is unique. Now, being unique is supposed to have two values, one for x and one for y, that hold for both of these two equations. So, after getting the value of y as 2, what do? What did we say in the previous example? We said that now, substitute for y is equal to 2 in any of the original equations. How do you substitute? You can use this, you can use that. So either way it works. I'm going to use equation 2. Using equation 2, where I have that x plus 3y is equal to 9, but the value of y being 2, I'll have x plus 3 times 2 here should be equal to 9. That will give us x plus 6 is equal to 9. So what do? We take 6 from this side of the equation to the other side of the equation. The moment it jumps, the equal sign becomes a negative because we have done subtraction this way, so we do the same the other side. We are going to have here x plus 6 less 6 is 9 less 6. So we have x here as 3. So after having the value of x and the value of y, we can come now and say, therefore, that the solution is x is equal to 3, where y is equal to 2. This is our required solution. But is it true? We could come and confirm. Let's say we're having 2 times 3 or plus 2. This gives us 8. So I think the first one holds. So we can say, now we are okay, that's true. Come down to the second one. X is 3, so put here 3. 2 times the value of y is 2. So put it there. So this is 3 times 2. This will give us 3 plus 6 to give us 9. So this one holds true as well. Then we can smell and say that now our solution is all right. So with those two examples, I'm confident that you'll be in position to solve the simultaneous equation using the elimination approach. So what I'm going to do is give you an exercise of 2 numbers to try out during your free time. After you've left the TV, simply try out these. So this is your exercise. Let's solve the pairs of simultaneous equations below by elimination method. So the first one is here. We're having 2x minus 3y is equal to 7. Whereas its sister equation is x plus 4y is equal to negative 2. And then 2, please you have 2x plus y is equal to 2y plus x is equal to 8. And then its sister equation is 1 plus y is equal to 2x. Please try this out using this approach that we've had, step by step, step by step. Having done that, we now move on to our last method. And this is the matrix method. So to take you through this, I'll give you an example, and then I'll take you through step by step and what to do. So here we are having, let's solve the simultaneous equations below by matrix method. And here they are. We're having x plus y is equal to 6, and then 2x minus y is equal to 6. That's the example we had at the beginning. We're going to see whether this method also uses the same result as before. Now, we need to make sure, before we move, that our equations are arranged in such a way that the unknowns are aligned together. If the first one is x, we should have x here as well. If here we have y, we should have y here as well. That should be the first step. Before you move any further, arrange your equations so that the variables are aligned vertically. X, x, y, y. And then you can move on. Then the next step here you're going to do is extract the coefficient matrix. In other words, write this one in matrix form. Look at the first equation and ask yourself, what is the coefficient of x here? We're going to have here is 1. Ask yourself, what's the coefficient of x here? That's 2. What's the coefficient of y here? And that's 1. The coefficient of y here is -1. Please multiply this one by the matrix of the variables, that is x, y, and equate this one to the matrix of the constants, that is 6 and 6. And there you are. So this is already in matrix form. So what do you do from here? You are going to obtain the adjoint matrix of 1, 2, 1, -1. Get the adjoint of this one. Here, our adjoint matrix is, now it is that matrix in which the elements in the major diagonal switch places. These ones change places. In other words, what is here goes there, what's there comes here. So you're going to have here -1, 1. Then this is our minor diagonal. These ones change signs. So we're going to have here, because it is +2, we shall have -2 here. +1, we shall have -1 here. That is your adjoint matrix. This one is the major diagonal. This is the minor diagonal. The next step is to pre-multiply the adjoint matrix on either side. On either side of the equal sign. What are we going to do? We are going to get our adjoint matrix, -1, -2, -1, 1. Multiply this one with 1, 2, 1, -1. This is 1, 2, 1, -1, followed by x, y. Now, because we are introducing something that is not there in our matrix equation, when we do it on the left, we do it on the right as well. So we shall have again the adjoint matrix 1, -1 here, -2, 1, pre-multiplying the constant matrix 6, 6. Like that. Then we move on. Please realize that when we do this, we are going to use matrix multiplication. Now, to multiply a matrix, please realize that 1, we are multiplying a row with a column. Row with a column. Row with a column. But the number of columns in the first matrix should be equal to the number of rows in the second matrix. If that's not true, then there is no compatibility and you cannot do the multiplication. So, on the left-hand side, we are going to have this row with that column, negative 1 times 1, added to negative 1 times 2. Then, when we do that, we obtain the first entry of our matrix. The next entry of our matrix is going to be obtained by multiplying this row with that column, where we have negative 1 times 1, negative 1 times negative 1. So we are going to have here negative 1 times 1 plus negative 1 times negative 1. So we're going to bracket that up like that. Next, to get the entry here and here, we are going to use the second row and the first column, where we are going to have negative 2 times 1. This multiplying that. Then this multiplying that. Plus 1 times 2. Then we move ahead and multiply this down row with the second column. It is this with that, where we're having negative 2 multiplied by a positive 1, added to 1 multiplying a negative 1. 1 times negative 1. Put here your x, y, then come onto the other side. We are multiplying a row with a column, where we're having negative 1 times positive 6, added to negative 1 times a positive 6. Whereas here we are going to have this row multiplying that column, where we're having negative 2 multiplying a positive 6. And then we are going to add that to positive 1 multiplying a positive 6. So, that being done, we now simplify this one. Please realize that we're having a negative 1 and a negative 2 that will give us a negative 3. Whereas here, we're having a negative 2 plus 2, this would give us a 0. Likewise, negative 1 plus 1, because we have negative, negative, is going to give us a 0. And then here we are having a negative 3, and so a negative 2 added to a negative 1 to give us a negative 3. Bring your matrix for the variables there, then equate it to the sum. We're having negative 6 and negative 6, that would give us negative 12. Please look at this. We're having a negative 12 plus 6, that will give us a negative 6 there. Now what we are left with is the multiplication. We are multiplying a row with a column. We're multiplying a row with a column. So we are going to have here negative 3 times x plus 0 times y to be equal to the first entry there, which is equal to negative 12. And then we are going to have here 0 times x plus negative 3 times y to give us negative 3y is equal to the second entry there, which is negative 6. Now we have these two equations. This one, we are going to drop the y and we have negative 3x is equal to negative 12. So what we do here, we are going to divide through by negative 3, and this is going to give us x as 4. On this side here, we are going to drop the 0, and then we are going to have negative 3y is equal to negative 6. So what we do here, we are going to divide by negative 3. And this is going to give us y as 2. So we come here and say that therefore our solution is x is equal to 4 and y is equal to 2. That is your solution, which you can bring and paste in this equation to prove the validity of your answer, and paste in this equation to prove the validity of the answer. So here we are going to have 4 plus 2, which is actually equal to 6. Whereas here we are going to have 2 times 4 minus 2. So we are okay. That's your matrix method. Please, please, please realize that you extract the coefficient matrix, get the adjoint of that matrix, pre-multiply the adjoint on the left and the right, then use the rules of matrix multiplication where we multiply a row with a column, reduce your matrix, multiply through, drop the 0, find the value of x, multiply through, drop the 0, find the value of y. Step by step. Easy does it. Now, supposing we don't do that, I'm going to use the same example to help us. We're having x plus y is equal to 6, and then 2x minus y is equal to 6. We have extracted our matrix, which is 1, 2. 1, negative 1 into xy to be equal to 6, 6, like that. We've gone ahead to obtain the adjoint, which is negative 1, negative 2, negative 1, 1, as previously. So what do we do next? Here, we can find the inverse. Find the determinant. Find the determinant of this matrix here. Negative 1, negative 2, negative 1, 1. No. Okay. Find the determinant of the matrix 1, 2, 1, negative 1. That is, the determinant is going to be equal to the difference between the product of the elements in the major diagonal, which is 1 times negative 1 less, and then the product of the elements in the minor diagonal, which is 2 times 1. This gives us negative 1 minus 2 to give us negative 3 there. So after having done that, we are going to obtain the inverse of the matrix 1, 2, 1, negative 1, which is going to be equal to 1 over the determinant times the adjoint. Now 1 over the determinant being -3, the adjoint matrix being -1, -2, -1, 1. There, that's your inverse of the matrix, this one. In which case, after having obtained it, what do we do with it? What we do with it is this one. After getting the inverse, we are going to come and say that multiply both sides of the matrix equation by the inverse. Now, when you do that, on the left, we shall have an identity matrix, which is 1, 0, 0, 1. So we can ignore that one, which is going to give us x, y to be equal to 1 over the determinant, it is -1, -2, -1, 1, multiplied by the matrix of the constants here. Please realize that we can multiply a row with a column, where we're having -1 times that gives us -6 plus -6, and then we have here -12 plus 6. This is going to give us -1 over 3 into -12, and then here -6. Now, realize further that this constant term here pre-multiplies everything within the bracket, the matrix here. So you're going to have -1 over 3 times -12, and then -1 over 3 times -6. This generates, we're going to have here that your xy, therefore, is, when you divide through by 3, 1, by 3, 4. -1, -4 gives us a +4. Then we can have by 3, 1, by 3, 2. -1 multiplied by -2. This would give us a +2. Therefore, the value of x is equal to 4 when the value of y is equal to 2. Now, these two values are the ones we obtained previously. When pasted into these two equations, please realize that the equations hold true. Now, if they hold true, then that's okay. Now, you can ask yourself, why have I not multiplied here by the inverse? I have done that, but I'm using the fact that a matrix multiplied by its inverse gives us the identity matrix. That is, when I have -1 over 3 into not, but into 1, 2, no, not this one, into -1, -2, -1, 1, and I multiply this one with 1, 2, 1, -1. This is going to give me the identity matrix I with elements 1, 0, 0, 1. That's why I've ignored this one. Because when I multiply 1, 0, 0, 1 with xy, I come up with xy. That's why I have not put it here. So, if you have grasped that, I thank you so much. And I'm always grateful that you have got it. Now, if you haven't got it, please revisit whatever we have done to help you understand better. Please help me solve these equations. Solve the following equations. the following simultaneous equations. The matrix method. 1, I have here 2x minus 3y is equal to 7. And then its sister equation is 14 plus 4y is equal to 5x. So I'd like you to solve that one. I could give you another one, but first try out that one and see whether you are on track or not. I remain yours, Chintu Herbert, your teacher of mathematics, courtesy of Seroma Christian High School. I'd like to wish you a very nice day, and God bless you all wherever you are. We meet again when the Lord wishes us to be. Bless you.